You bought the mobile proxy, you plugged it in, your tool says it is connected, and you assume you are safe. Here is the uncomfortable truth. A request can route through your proxy and still hand the other side your real IP. It happens quietly, it happens to careful people, and most of them never find out until an account gets flagged. This video shows you how to actually test for it step by step so you know your proxy is hiding you instead of just feeling like it is. I run a hardware proxy farm here in Singapore. Real phones, real SIM cards from Singtel, M1 and StarHub. So I verify these exact connections every single day, and I have watched every one of the leaks I am about to show you slip past someone who swore their setup was clean. The people who get caught are almost never careless. They are usually the ones who tested once, saw a Singapore IP, and never looked at the other doors. So let me start with what a leak even is, because the word gets thrown around loosely. A leak is any path that lets the destination or some service in the middle learn something true about you that your proxy was supposed to hide. Usually that means your real IP, but it can also be your real DNS resolver, your real location, or your real time zones. The traffic looks proxied. The tail rides alongside it. The reason this is possible is that a proxy only carries the traffic you actually send through it. Your machine has other ways of talking to the network, and several of them do not go through the proxy unless you force them to. Your browser, your operating system, and your tools all make side connections you never asked for. Those side connections are where you get caught. It helps to picture it as a building with one front door and several windows. The proxy is the front door, and your main traffic walks through it. But DNS, WebRTC, and IPv6 are windows that nobody bothered to lock. You can guard the front door perfectly and still have someone climb in through a window you forgot existed. The first thing to check is the easy one, your exit IP. Turn the proxy on and visit a simple "What is my IP" page or an IP info service. You want two things to be true. 1. The IP is not your home IP. 2. And people forget this part, the IP belongs to the mobile carrier you are paying for, not a hosting company. Look closely at what that page calls the org or the ISP field, because this is where the second tell hides. If it shows Singtel or M1 or StarHub, good, you are on a real mobile network. If it shows a hosting company, a cloud provider, or a name you do not recognize, you are not on a real mobile IP, and that is a different problem worth solving before you go any further. A lot of so-called mobile proxies are really data center IPs wearing a label, and the org field is where the costume slips. While you are there, also check the ASN, which is the number that identifies who owns that block of EPs. A genuine carrier IP sits on a carrier ASN, and a data center IP sits on a hosting ASN, no matter what the marketing says. The ASN does not lie the way a friendly product name can, so when in doubt, trust the ASN over the label. Now the one that undoes everything else, the DNS leak. When your computer wants to reach a website, it first asks a DNS resolver to turn the name into a number. If that question goes out on your real connection instead of through the proxy, you have just told your own ISP every site you are about to visit, and you have handed a strong location signal to anyone correlating it. Your traffic can be perfectly proxied, and this lookup still walks out the front door. To test it, keep the proxy on and load a DNS leak checker. Read the resolvers it reports back. They should sit in Singapore, on the tunnel, consistent with your exit IP. If you see your home ISP's resolver, or a resolver in your real country, that is a live DNS leak and you fix it before anything else. Here is a subtle version of this that trips people up. You might see a resolver that is not your ISP but is also not Singapore. Maybe it is a public resolver run by a big provider in another region. That still counts as a leak, because the geographic origin of that lookup does not match the IP you are presenting. And that mismatch is exactly what a careful service is watching for. The fix on the SOCKS 5 side is one letter. Use SOCKS 5H with the H on the end, not plain SOCKS 5. That H tells your tool to resolve DNS through the proxy instead of on your own machine. Without it, your computer does the lookup locally first, and the proxy never sees it. If you take one thing from this whole video, take the H. A common trap with the H is that you set it in one place and forget another. You fix it in your scraper, but your browser is still on plain SOCKS 5. Or you fix the browser, but a separate tool on the same machine is leaking on its own. Every client that touches the network needs its own correct setting. The proxy cannot enforce this for you because the leak happens before the request ever reaches the proxy. The next leak lives inside your browser, and it is the sneakiest WebRTC. WebRTC is the technology browsers use for voice and video calls, and to make those calls connect, it tries to discover your real network addresses. It does this with something called a stun request, which can reveal both your local IP and your real public IP directly, completely sidestepping your proxy. Your page traffic is proxied. WebRTC quietly waves your real address at the room. You test this the same calm way. With the proxy active, open a WebRTC leak page and look at the addresses it finds. The page will usually show a local address and a public address. The local one often looks like a private range and is less of a concern on its own. The one that matters is the public address. If your real public IP shows up there, you have a WebRTC leak even though everything else looks fine. The fix is to disable WebRTC in the browser or use an extension or an anti-detect profile that blocks it. Then load the test again and confirm your real IP is gone. Be careful with the half measures here. Some extensions only hide the local address and leave the public one exposed, which gives you a false sense of safety. After you apply a fix, always rerun the test and read the public line specifically, not just the overall green checkmark. Then there is the one almost nobody checks, IPv6. Most mobile proxies hand you an IPv4 address, but your own machine and network may also have IPv6, and a lot of tools will quietly prefer IPv6 when it is available. So your tool reaches for the IPv6 path. That path was never proxied, and it sails straight around your IPv4 only proxy carrying your real address. This one is dangerous precisely because it is intermittent. On a network with no IPv6, it never fires, so you test at home and everything looks clean. Then you move to a coffee shop or a different office that does have IPv6, and suddenly the same setup leaks without you changing a thing. A leak that only appears on some networks is the hardest kind to trust around. To catch it, use a test page that reports both your IPv4 and your IPv6 result while the proxy is on. If the IPv6 line shows a real address tied to you, that is your leak. The clean fix is usually to disable IPv6 on the connection you are testing, so everything is forced down the proxied IPv4 path, unless your provider explicitly handles IPv6 for you. There is also a softer tell that is not strictly a leak, but gives you away just the same, a time zone or locale mismatch. Your exit IP says Singapore, but your browser still reports a time zone from your real country, or a system language that does not fit. On its own, it proves nothing. Stacked next to a perfect IP, it reads as someone pretending, and detection systems love that kind of contradiction. Set your time zone and locale to match the IP you are presenting. One more edge case worth naming: the system level versus the app level. Some people set a proxy inside one application and assume the whole machine is covered. It is not. Anything outside that app, including operating system update checks and background services, can still reach the network directly on your real IP. If you need everything covered, proxy at the level that catches everything, not just the one tool you were thinking about. So here is the simple, repeatable routine I want you to run every time you start on a fresh proxy, before you trust it with anything. Turn the proxy on, check your exit IP and confirm it is the carrier, not a data center, by reading the org and the ASN. Run a DNS leak test and confirm the resolvers sit on the tunnel. Run a WebRTC test and confirm your real public IP does not appear. Check IPv4 and IPv6 and confirm nothing leaks on the IPv6 side. Glance at your time zones and locale and confirm they match the exit. 5 quick checks and you know. Do that once per environment and again anytime you change tools or browsers, because a new browser update or a new profile can quietly turn WebRTC or IPv6 back on without telling you. I also rerun the DNS check after any network change, because moving between networks is exactly when a quiet IPv6 path or a different default resolver shows up. The whole point is that you stop guessing. You either watched your real IP stay hidden across all 5 checks, or you found exactly which door was open and you shut it. One habit that has saved me more than once: write down what good looks like for each check the first time you pass it. The expected carrier name, the expected resolver region, a clean WebRTC result. Then every future test is a comparison against a known good baseline, and drift jumps out at you immediately. Now the honest operator angle, because this is where the setup matters. A lot of these leaks get harder to trip when you start from a real mobile IP with DNS that actually routes through the tunnel, instead of a setup that proxies your page traffic but leaves your resolver exposed. That is the part 1 built around. Real Singapore mobile IPs from actual Singtel, M1, and StarHub SIMs, sticky sessions so your IP holds steady, and DNS that routes through the tunnel so you stop leaking your real resolver. You still run the 5 checks, you just pass more of them by default. I want to be straight about that last point. A good proxy fixes the DNS side and gives you a real carrier IP, but it cannot reach into your browser and turn off WebRTC for you, and it cannot force your machine to stop preferring IPv6. Those two stay your job. So the proxy removes the leaks it can own, and the routine catches the ones that live on your side. You need both, and anyone telling you a proxy alone makes you leak-proof is selling you something. If you want to test your own setup against real Singapore carrier IPs, grab a trial at singaporemobileproxy.com/client/trial and use code YT30 for 30% off your first month. Provision a port, then run the exact routine from this video against it. Exit IP, DNS, Webpack, IPv6, time zones. 30 minutes tells you whether your foundation is real before you build anything on top of it.
Subscribe if this was useful. I ship 2 new videos every weekday, and the next ones go deeper on doing this right.